Hello everyone, Nate here, back with another episode of the Show About Science. And today, could we build a city on Mars? Should we? And have we really thought this through? We'll get to those questions right after a quick break. So, we're back.
How's my sound? Is it decent?
Sounds pretty good, I think. To talk about settling the stars. Specifically Mars. Or maybe the moon.
All right.
Okay,
let's do it.
Perfect. Hello?
Hello.
So, this is Zach Weinersmith, correct?
Yeah, oh yeah, yep. The most embarrassing pronunciation possible is the correct one.
Lovely. And you wrote a book called A City on Mars with your wife, Kelly Weinersmith?
That's right.
All right. Could you tell our listeners a little bit about yourself and a little bit about the book?
Yeah, totally. And since Kelly couldn't make it because she's sick, she is a professor of parasitology and adjunct professor at Rice University who studies gull wasps, among other things. And I am a cartoonist and author, I guess I'd say. And then she and I write popular science from time to time. And this latest book is a kind of a weird book. It was actually initially pitched to our editor as Space Settlement is cool and it's going to happen soon. So we should sort of analyze it and lay it out for people. And we came to think basically that it remains cool, but is pretty unlikely in the short term. It's probably not going to make anyone a lot of money. And there are reasons to be concerned that maybe we actually shouldn't do it in the short term.
Okay, let's just lay it all out. Why wouldn't we be able to start putting space settlements on the moon or Mars? Why wouldn't we be able to do that?
Yeah, so there are a bunch of reasons. The place I would start is that you watch movies and you have this idea that space is really big. And that's true, of course. Space is quite big, but the amount of places you could put people and they would have a chance of surviving with really advanced technology is quite small, right? So, the first planet from the sun is Mercury, which is just incredibly hot. And it's actually quite hard to reach because you have to kind of drop down toward the sun and then carefully swing into orbit. So that's basically not going to happen. Venus is like 100 times Earth pressure. I think it's a little under that, but it's just crazy high pressure, ultra hot. There are acid clouds. It's just absolute doom. So that's not happening. You get to Earth, which is a lovely place. Most of my friends are there. And then you have Mars and, of course, Earth's moon. And those are probably the most likely places. But the thing to understand is they are still really awful. And without getting way into the weeds, a short list of problems would be that, of course, there's no air. You are getting much higher doses of radiation because on Earth we're protected by our atmosphere and magnetosphere. And then there's like subtle stuff, right? So the surface of the moon, if you see a picture, it just looks kind of like gray, plastery dust. But actually, if you put that stuff under a microscope, it's sharp. And some of the pieces actually look like knives. It's made of stone and glass. And the reason, if you want to think about it, it's like there's no flowing water, there's no wind, there's no life like nuzzling around in the ground. There's just this surface that's been thwacked by asteroids and micrometeorites and radiation and whatever for billions of years. And so you imagine something that gets heated and then broken and then heated and broken. Eventually, it's going to look like tiny little knives.
Very fun to walk around on.
Yeah. Well, the Apollo guys, the astronauts actually went there. They described it like it was alive because it's charged, right? It's got static charge. And so if you fall in it, it sort of sticks to you. And one guy, I think it was Harrison Schmitt, who was Apollo 17, reported that he breathed it in and it was like having an allergic reaction. The basic deal is the environment is really, really hostile. I would say it'd be much easier to put a city on the bottom of the ocean than to do it anywhere in space.
Okay. Let's say we find a good place to settle on either the moon or on Mars. Would there be any other challenges to setting up a colony or a settlement?
Yeah, so there are going to be a lot of practical challenges. So first, because the environment is so extremely hostile, the first thing you want to do is keep the environment out, right? So, there are different ways to do that. A sort of basic way, which is probably the first way we'll do if we put, say, a moon base down, is you will just fit something like a cylinder right, in the top of a rocket. So the top of a rocket, the payload part is called a fairing. So you would just fit a cylinder in there and land it on the moon and basically not interact with the moon other than like experiencing its gravity, right? You're just showing that you could be there.
And what if you wanted to build a space base?
Yeah, so if you want to build a space base, there are basically two areas that are worth considering. One is what are called lava tubes. So you could think of these as just enormous caves. We have them on Earth. Any planet that's ever had flowing lava will create lava tubes. And there are a couple ways you can do it, but basically, if you want to imagine it, imagine like molten stone is just sort of flowing, and then it forms a roof when the top cools, but the inside part keeps flowing. It's kind of kept hot like a thermos because the top is cooled stone. Does that make sense?
Yeah. So the top cools, and eventually the lava that's still in the tube flows somewhere else, and then you're just left with this sort of cave or tunnel thing.
Yeah, that's a good way to think about it. In practice, they can be more like an anthill or something, but that's a good way to think about it. And so, if you go to Hawaii or the Pacific Northwest and other places on Earth, you can visit these. But on the moon, you have 1/6 of Earth's gravity, right? Much lower gravity. Like I could slam dunk on the moon, which I'm like feeble and pathetic, and I could do it. And so the result of that is that when these tubes form, we think they could be hundreds of times bigger than the ones on the Earth. So if you imagine wanting to build a space base, right? Remember, your goal is to keep the moon out. You want to stay in this thing. The idea is instead of having to like situate a pre-built structure, like a building in the top of a rocket, you would instead bring a sort of plastic spray on, and you would go in the cave and then you would seal it up. So you'd have your bubble pre-built, and then you could just pipe in oxygen and you could live there. The other most desirable spots that I'm worried actually countries might fight over is what are called the peaks of eternal light. And so the way I explain this is, if you imagine the Earth is rotating, it's slightly at an angle, right? It rotates on its axis. That's why we have seasons. If you imagine you sat like a cup on top of the moon, like a huge cup, you couldn't do this in real life, but just imagine it's huge. So the sun is going to hit the moon as it rotates on one side, but inside the cup, it'll be dark all the time. And at the rim of the cup, it'll be bright all the time. Does that make sense?
Yeah.
Yeah, no, it's a little hard to visualize. The demo I like to do is if you imagine you have a dark room and you have a flashlight on one end and you take a beach ball and then you tape a plastic cup to the top and then spin the ball, you will see like the ball itself will get like a day-night cycle. One side will be dark because it's opposite of the flashlight, and one side will be bright because it's into the flashlight. So that's what happens on the moon naturally, right? So the moon has 2 weeks light, 2 weeks dark. That's what moon day and night is like. But if you have this cup at the top, the very tippy top of the cup will always be grazed by some amount of sun. And then inside the cup, at the very bottom, there will be no way for light to get in because it's blocked by the rim of the cup. So something like this actually happens on the moon in craters, because a crater has a kind of bowl-like shape. And the result of that is that the rims get almost perpetual sunlight. And the crater inside the rim, it's almost always dark. So there is water ice there. So if you're imagining building a moon base, or even if you're just like writing a story about where you would put it, this is the place where you get energy and water all the time. So that's where I would probably put my base if I were setting up on the moon.
So we would probably either end up living in a lava cave, or we would end up living in a crater that always receives some energy from the sun and has both ice and water. And you mentioned that those would be the places that governments would probably end up fighting over.
Yeah.
So do we think that that would actually be feasible in space? And what could some of the ramifications be for a possible settlement?
I would say it's possible. Right now, it would be very expensive. And I would say the main thing that I would worry about is there are actual rules right now for how countries are supposed to behave in space. There was a treaty called the Outer Space Treaty. It was signed in 1967. It's generally considered the rules. But rules between countries aren't like the rules inside countries, right? So in our country, if you go, rob a bank, you go to jail, right? When countries do bad things to each other, it's a little more complicated. Countries kind of have to agree to punish or not. And so there are rules, but they're fuzzy. But one major thing the rules say is no country can claim a chunk of the moon. The moon, in some sense, either you could say it belongs to nobody or it belongs to everyone on Earth, right? Practically, it's kind of the same. So the concern is you're not allowed to claim space on the moon. Like you can't say, this is my country on the moon. You can't say this part of the moon is part of Canada or Japan or something. However, you can take as much as you want from the moon, meaning you can use up that water. You can situate a base on the crater. You can do all sorts of stuff. The most absurd example that I like to give is if you found an asteroid, like imagine a really big one, it would be illegal to start a country on the asteroid. It would probably be legal to grind up the entire asteroid, turn it into a spaceship, and claim it was yours, right?
Okay.
So you can imagine how you get into a situation where countries could really start fighting. The way I explained this to my daughter who's 9 was like, imagine you have a playground, and in theory, it's everyone's, but you can like go in with a hammer and beat up the slide if you want. Like an individual kid can just choose to do that. It's a really bad situation for everyone getting along, but it's what we have right now. And because those places I described, like the lava tubes and the unusual craters, they take up a very small amount of space. It's a tiny region of the moon. Depending on how you want to do the math, it's something like a couple hundred acres, which for reference would be a very small farm. Like that's it. So there's this concern we have that if countries decide it makes them better than each other if they have the best moon base, you worry you get into a situation where they start fighting.
So let's move away from the show about legality of space exploration and colonization and move back to the science part for a second. So could A, we survive and become self-sufficient anywhere on either planet? And would plants be able to grow or things like that?
That's a really important question. So I would say on the moon, basically no, and I'll tell you why. You may have seen a Pop Science article that says scientists grow plants in moon soil, and it's kind of true. But here's the thing. So the moon is very low in carbon, right? So human bodies are about 20% carbon. Plants tend to be a higher amount of carbon. And carbon is not something you can just make, right? It's an element. It gets made in stars. So you cannot get more of it. The only way you could get carbon to the moon would be to like either bring it from Earth at great expense. There are carbon-based asteroids. You could send down an asteroid. We were joking, probably the most concentrated source of carbon on the surface of the moon is the leftover bags of poop from Apollo astronauts. That would be the place to start. So no, you can't really be self-sufficient on the moon. Also, the other thing is like the moon has water, but not much. People often talk about what we should do with all this water on the moon. There's actually not much. There's about as much as like a small lake, and it never replenishes. Mars is a different case. So generally speaking, when we talk about wanting a settlement that's permanent, as you say, Mars is the place. And the reason is Mars has the same chemistry as the Earth, so to speak. So there's carbon, there's nitrogen. Crucially, Mars has an atmosphere. It's a very thin atmosphere. You're still super, super dead if you go outside of your habitat. But the atmosphere is made of carbon dioxide. So that means you have, like, just from the air, if you have enough energy, you can get carbon and you can get oxygen, which means you can breathe. And I won't get into the chemistry, but if you have a source of hydrogen, which could be brought in or gotten from the environment, you essentially are able to make water, you're able to make oxygen, and you're able to make rocket propellant and batteries. So it's all expensive, extraordinarily dangerous, but at least in principle, you could do it. You could make a settlement that could survive loss of contact with Earth. But, oh yes, your other question was plants. So sometimes, and this I find frustrating, you will read an article that says, plant was grown in moon soil. What actually has been done is, in 2 cases that I know of, scientists have been allowed to use Apollo-era moon soil. But it has been supplemented with nutrients, sunlight, water, and an atmosphere. And so the way I like to say it is like almost anything in your life could be ground up and you could grow a plant in it if you gave it nutrients, atmosphere, sunlight, and oxygen. Like I could take I don't know, I'm looking around this room, like I could take my desk and grind it into powder. And unless like the lacquer on it is made of plant poison, plants will grow in it. And in fact, the plants that were grown in real moon soil looked stressed, maybe because of the regolith being these little knife-like structures. On Mars, we know even less. So no one's ever grown plants in Mars soil. Again, you'll sometimes see articles that say they've used Mars simulating soil, but that soil doesn't actually simulate Martian soil at the chemical level. So and again, I don't want to get into the fussy details, but really important. there's a chemical that all the soil on Mars is laden with. It's called perchlorate. It's used in dry cleaning. It disrupts thyroid hormones, and that has all sorts of bad effects. We think it would probably be extraordinarily bad for kids your age because, most people who've gone to space have fully developed bodies. It would probably be very bad to give someone a hormone disruptor at a young age. And so that's a real danger. And there are ways to fix that. But I would be concerned about any farm on Mars trying to grow in soil with these toxins in it. You'd really want to prove that it was safe. And that would take a lot of time and money.
So what are some of the other different ways that if you were going to start a settlement on Mars, how would space be trying to kill you?
Loads of ways. So the first thing to know about trying to start a settlement on Mars, so one good thing about the moon is with the current technology, it's about 2 days there and 2 days back. And the moon is always the same distance. You can always leave from the moon to Earth. Mars is not like that. So Mars years are about 600 days. So that means they're both rotating around the sun roughly in circles, but the Earth is going around faster, right? It's got a shorter year. So there's a certain point at which they're aligned, meaning if you had a giant stick that was going for the middle of the sun, it could skewer both Earth and Mars going in one direction. That briefly happens, and then Earth races ahead. So if you want to throw a spaceship from Earth to Mars, usually what we do is what's called a Hohmann transfer, which just means the lowest energy way to do it. And so if you imagine it, you kind of throw it, and it's being pulled in by the sun, and just as it slows down, it intersects with where Mars is and then drops into orbit. It takes about 6 months to do that inbound. So that's task number one. Astronauts have got to survive the inbound trip, which is 6 months. Probably they're getting a heavy dose of radiation. There's a small but real danger that they could get hit by a storm of radiation. Now and then the sun shoots out these blasts of radiation that could give you what's called radiation sickness, which probably will kill you. There have been times in the past when these storms have gone straight at Earth, and there are stories from the 19th century where electric equipment just suddenly starts sparking. It's not good. But okay, you survived 6 months. Hopefully you brought enough food and water and changes of underwear and everything else you need. You have to land on Mars, which is extraordinarily difficult because the atmosphere is so thin. So when we try to land on Earth from a rocket, outside of the shuttle area, usually you'd come down in a capsule, which has this sort of shield-shaped front that just thwacks into the atmosphere, and actually parts of it ablate away, meaning they get destroyed by heat. And that slows you down drastically. And you can't really do that on Mars. So that's why when we have rovers now, they have to actually use these complicated systems with retro rockets and other stuff to gently lower something to the surface. It's very difficult. But let's say you've done that. The first thing you're going to want to do is start farming if you can. I mean, so if this is just you're sending 6 people, then you're just going to try to survive, and you're probably going to eat dried foods or whatever, right? But if you want to survive, you need to set up a farm in a bubble, which is extremely difficult.
So let's say that you've managed to survive. Extremely difficult, but let's say you've done it. And you've lived on Mars for a year. So then at that point, how long would it take to get back to Earth?
Yeah, so I should say for all this, I'm assuming there's no cool advanced super technology that changes everything.
Right.
But typically you'd say about 6 months home. So very roughly speaking, 6 months inbound, over a year there, 6 months home. And with the additional challenge that in most proposals, you have to make your fuel on site. So hopefully nothing goes wrong with that.
So assuming nothing goes wrong with that part, if we actually wanted to start settling Mars, what would be the ways that we would end up doing it in your opinion?
So what I would say is, suppose we knew a comet was going to destroy Earth in 50 years, and we were we've got to get everybody to Mars, right? What would you do? So Mars does have lava tubes. That might be a good bet. Another good bet might be the poles, because the poles have lots of water ice. Another bet might be the equator, which, if you can believe it, has a temperature similar to Earth. And also, if you dig down far enough, we think there's water there. So what you would want to do is make your pick of those. I guess if it were me, I would say go with the lava tubes, but it kind of depends on what your goal is. The poles are also quite tempting because of all that water, which is very useful. But let's say you go in the lava tubes. First order of business, you need to create an ecosystem. So we don't know how to do this. It's only been tried a couple times. Like, can you create an ecosystem in a sealed container, right? People do this for souvenirs, like a little glass bubble with like some moss in it, and it will survive for a long time. But to do it at scale where humans can survive inside it is really hard. But if you can get it working, it provides a lot of services. It's not just food. It's plants that photosynthesize, meaning they create oxygen for you. And they remove your carbon dioxide, which is toxic to humans at fairly low concentration. Like once it's up to like 1% of the atmosphere, you start having problems. It also, though, is going to filter your water and waste, right? So you want to deal with all the human waste products. Earth's biosphere does that for us naturally. You want to try to recreate that. The largest such experiment ever done was done in the 1990s, and it had 8 humans inside. And they were in a 3-acre facility that's, about 3 football fields, right?
Right.
And they did go in. It was fairly tightly sealed. At one point, they were starving. Actually, they came out starving. They lost 10 to 18% of their body weight, and they weren't super chubby to begin with. And also, they at one point were running out of air. And we now know what happened is the structure itself was sort of chemically pulling oxygen out of the system.
Ew.
But the good news is they did survive. Although, what's funny is they got in fights. So like really quickly, they split into 2 groups of 4 at one point. And these are adults. At one point, one group like came by and spat on the other. That's how bad it was. But the important thing is, so this experiment got shut down after a little over 2 years. And a lot of stuff went wrong. So for example, they got these pigs. They thought they were going to be able to raise pigs. And the pigs just kind of ran amok and destroyed stuff and ate plants. And they got this weird species of chickens they thought was going to be really good. And it didn't lay any eggs, or didn't lay many. And they made a lot of just silly mistakes. They were growing mango trees that take 4 years to fruit, so they got nothing out of them. But, they survived. So that's something.
Right.
Yeah, right.
Yeah.
It's something. The problem is, Earth has 7 billion people. And assuming that experiment was about the right size, which we don't know, to scale it to 1 million people, which would still be, only 10% of New York City, roughly, you would need a greenhouse the size of a city. Which not only would it be very hard to construct, especially on Mars, you have to imagine getting all that equipment there, but also we don't know how to do the part where you design an ecosystem. It's obviously just never come up on Earth. On Earth, we get an ecosystem. It's just here. It's where we evolved. We don't know how to build one of these sealed ecosystems. It's actually, for me, one of the coolest sciences. Like if I had another career, going into how do you build an ecosystem that can make the most people survive with the least space is kind of fascinating. There's a couple experiments in Europe and one in Japan and one in China, but really we need a more detailed science. We need to know much more to be able to do that on Mars. But that would be really one of the most important things to accomplish.
So, is there any reason to be optimistic about space travel? Would there eventually maybe be a way that we could settle the stars?
Yeah, I probably sound very pessimistic as I talk, like I'm just saying, no, it's never going to happen. But the way I look at it is what you want to do is be realistic about the challenges, because then you can start putting the pieces together so that maybe, someone my age will not get to go there, but maybe someone your age will. And that requires a lot of work that needs to be happening now. And so what's exciting to me about that is the work is frankly kind of awesome. So it's stuff like we need to figure out, can you have babies in space? We have no idea. No idea at all. The science is very piecemeal. We know very little. There's a bunch of amazing work that needs to be done. What ideally you need is to build a huge piece of software that tells you how to design an ecosystem of varying sizes. That's just, to me, like the coolest science I can imagine. It's this awesome combination of plants and animals, but with technology to make sure everything's working. And then one real problem for any dream of going to space is that when you move stuff that is very heavy and very fast in space, it's dangerous to Earth, right? You ask the dinosaurs how they would feel about it, right?
Right.
The example I like to give is if an object going at 3 kilometers per second impacts Earth, has an explosion equivalent to if it was completely made of TNT, right? So objects in orbit go much faster than that. So a world with a lot of space infrastructure is a dangerous world for Earth. And so my view is the solution to that is we need an Earth that's just more harmonious. So if you look at what this planet was like, it doesn't feel very peaceful right now on our planet.
Right.
But it was probably a lot worse 150 years ago. And we have sort of slowly moved to a kind of system. It's called the rules-based international order. It's very imperfect. people don't always follow it, but we've slowly over time moved to a world where countries behave themselves a little more. And I think an amazing career for someone would be to, international law sounds boring, I think, especially if you're a kid, but it's one of the few fields where you can put your ideas on paper and they can shape the rest of history because you're deciding what countries are able to do with or against each other. And so people who were writing down ideas about how the ocean should work in the 17th century affect what boats can do on the sea now. And my view is if we want to settle space, if we want to have this vast infrastructure, if we want to be like in Star Trek, we have to have a more harmonious, cooperative planet first. And that's a big job that may take centuries, but we can all benefit from starting now.
So, once again, today's guest has been Zach Weinersmith, co-author of the book A City on Mars. Can we settle space? Should we settle space? And have we really thought this through? Zach, could you just let our listeners know where they could find your book?
You got it. It's available at bookstores and online. And as a note for parents, there's some sections that would require parental guidance, either because they deal with adult topics or violence. But I think it would be perfectly appropriate for a nerdy kid with some guidance.
All right. Thank you for being on the show.
Well, thanks for having me. It was a lot of fun.
There you have it, folks. The show about science is complete. Shout out to Christine and Molly at Penguin Random House for helping to set up this interview. And mad props to Zach and Kelly for taking us to Mars. We'll have the links to all of their books in the show notes. Music on today's episode comes from Descript and Epidemic Sound, and our theme song was written by Jeff, Dan, and Teresa Brooks. All right, Dad, you can shut the recording off.